In fact, our ability to see extremely far away allows us to glimpse back to a time not too distant from the Big Bang, 13.8 billion years ago. We now know the end of our world. Perhaps the Bible and our fondness for science fiction films would suggest a catastrophic end to the world. But what if we told you that the cosmos began and ended in the same way? The universe has ceased to expand, according to data from the James Webb Telescope. This prediction was made many years ago by popular physicist Brian Cox. By doing this, he provided us with the most grounded basis from which to conceive the end of the world. We need only turn to the oldest light in the universe, which, incidentally, is one of the arguments used by skeptics of the Big Bang Theory, light that started its trip before galaxies existed. It's easy to see, is the answer. We are in the direction of Big Bang 2.0. Come along as we discuss James Webb's startling finding and the reasons why the Earth has ceased to expand. If there is one thing about the universe and its history that we can be certain of, it is that the Big Bang is the focal point of our entire existence. Of course, other hypotheses, like everlasting inflation or an oscillating universe, also acknowledge the universe's beginnings, but we won't discuss the viability of these theories at this time. Primarily because theories that follow the Big Bang are likewise predicated on the same common moment of the universe's creation, and the astronomical world has now widely accepted that our history in this universe begins with the Big Bang. Although the Big Bang is a term frequently used in theoretical astronomy and space science, unless you're a nerd who has spent hours viewing some fantastic representation of the Big Bang, we rarely know the whys and hows of the occurrence. To be honest, there was more to the phenomenon than just a verbal eruption. In other words, the Big Bang originated from a single point that was extremely dense and infinitely hot. This point then expanded to great lengths. This entire event took place during the universe's really early stages. It's amazing to think that the cosmos was only 10 to the power of minus 34 seconds old when the Big Bang occurred. The age of that is 1/100th of a billionth of a trillionth of a second. This is the time of the infamous inflation or explosion, an enormous burst of expansion of the cosmos. The space expanded faster than the speed of light throughout this event. That's right. You wouldn't have even blinkered when the universe expanded from subatomic size to golf ball size nearly instantly, 90 times in a split second. The cosmos started to cool 1 second after the inflation, which is when matter as we know it today formed. In summary, the Big Bang left behind protons, neutrons, electrons, anti-electrons, photons, and neutrinos, among other particles. In less than a second, our universe was filled with all of these particles, whether they were intended or not. Mystical, yes? Though conceptually it appears to be so, our knowledge of the universe's beginnings is largely theoretical. Since the first moon landing, we've gone a long way and experienced exponential growth in technical innovation. Scientists studying the Big Bang would never have guessed that we would be investigating the possibility of life on Mars, based only on mathematical calculations and scientific models. Even while we have made significant progress in our efforts to explore space and research the cosmos, our current technological capabilities are still somewhat limited. You see, we are unable to reconstruct the Big Bang or observe the event from a distance. The most significant piece of evidence we have is from the cosmic microwave background, which has made it possible for scientists to see the Big Bang's echo. Although this process is revolutionary for the study of the universe, its theoretical applicability is restricted. The main drawback of this specific technology is that neither the gravitational waves nor the leftover radiation from the expansion itself are visible to us. Therefore, even though theory underpins all of our knowledge, scientific hypotheses are nevertheless subject to substantial criticism. Yes, we know a good deal about the Big Bang and how important it was to the creation of our universe, but we don't fully understand some of its consequences. Even more startling is the fact that most hypotheses regarding our universe are based on evidence that is constantly subject to human mistake. However, some of our data regarding the Big Bang is also very conclusive. To put it mildly, it's difficult to completely refute the hypothesis at this moment. Does the universe continue to expand? Over the past 10 years or more, the Hubble Space Telescope has been our sole hope for studying the Big Bang. Currently, though, all eyes are on the James Webb Space Telescope's exceptional precision. One of the main areas of disagreement in astronomical research before we had access to these strong technical tools was the universe's expansion. You would read about the expansion of the cosmos in scientific textbooks from the early 1990s. Put another way, one small piece of scientific knowledge that we've clung to is that the universe is expanding. The fundamental problem here, though, is that it's possible that we don't fully comprehend the implications of the universe's expansion. More significantly, we need to consider if the universe is indeed expanding. But the James Webb Space Telescope is telling us otherwise, so beware of spoilers. The universe has actually ceased expanding. We certainly have improved your internet experience, so while the globe is still intact, you might want to give it a try. We're glad to share our personal trick for safe browsing and getting access to deep block stuff in order to produce some really educational movies. The advocate for a secure and easily accessible internet, Atlas VPN, is the sponsor of today's film. With over 6 million users globally, Atlas is transforming the way that everyone plays the game. Okay, so this service won't work in space, but Atlas will provide a very fast and safe internet experience. Unable to see episodes that are region-locked? Once you connect to Atlas, you will enter a tiny virtual office. To use this service, you don't need to be an expert in technology or computers. It works flawlessly for everyone. Why choose for Atlas? Atlas stops malware assaults, protects your searches, unlocks global content, and provides the best available prices. At an absurdly low cost, secure your privacy and enjoy a plethora of advantages from Atlas VPN. Before delving into the ramifications of this revolutionary deviation from the course of our universe, let us first discuss how we now comprehend this puzzling phenomena. The revelation itself is really terrifying, and although it comes as no great surprise, it clarifies the possibility of a collapse in our universe. When the energy density of the cosmos is sufficiently high, the universe will eventually cease to expand. It appears like the universe is regressing. Now, let's examine this. In the 1990s, NASA and its reputable scientists came up with some extremely firm theories on the universe's expansion, with gravity serving as the cornerstone of their knowledge. This is still the case, however, new theories about how quickly the universe is expanding have been proposed. Scientists hypothesized that the cosmos might collapse again, stopping the universe's current expansion. But an even more horrifying hypothesis was put forth. If there was insufficient energy density, the universe would continue to expand indefinitely. It was challenging to locate concrete or observational evidence back then due to a lack of technology. One thing about the aging of our universe that scientists were convinced of was that gravity will eventually slow down the rate of expansion. It made intuitive sense, since galaxies are drawn together by gravity. Gravitational pull prevented the distances between celestial objects from growing as the cosmos expanded, preserving matter. Predicting the pace of expansion of the cosmos was another extension of the idea. It was anticipated that the expansion rate would slow down since gravity, which has existed since the beginning of the universe, serves as the binding agent for all matter. Up until the Hubble Space Telescope, HST, was developed in 1998, this hypothesis made perfect sense. After that, our understanding of the cosmos was completely altered. The study of far-off supernovas, which provided an explanation for space's fluidity, was made possible by the HST. Scientists were astounded by the results since they were wholly at odds with their prior knowledge. For the first time, astronomical research were believed by sight. It turned out that the cosmos was expanding at a very high speed, unaffected by gravity. Instead, the cosmos was expanding faster than it had ever done before. This surprising theory defied easy explanation. Gravity was supposed to be struggling to slow down the universe's expansion, but from all accounts, it was helpless. Until an anti-gravitational force was outweighing gravity, scientists still don't know why the cosmos was growing at such an incredible rate. Most scientists thought that dark energy and gravity were at war in our universe until the James Webb Space Telescope's recent discovery. The scientific community was in disarray following the discovery of Hubble as organizations like NASA looked for hasty answers for the extraordinary cosmic acceleration. There was a theory suggesting that Einstein's theory of gravity might not be valid. The idea states that gravity, which is understood as a distortion of space and time brought about by mass and energy, should have stopped accelerated expansion. Another idea that came and passed was that the expansion is being accelerated by some energy fluid. These days, there's just one explanation for Hubble's incredible finding, and that's called dark energy. Nevertheless, other than the fact that it comprises most of our cosmos, we know very little about this force. 5% of our cosmos is made up of regular matter, which is almost unsettling. Dark energy and matter make up the remainder. Furthermore, this demonstrates the existence of Einstein's infamous cosmological constant, a force unadulterated by expansion of the cosmos. How then does this connect to the observations made by the James Webb Telescope? In the presence of, why has the expansion of our universe stopped? Dark matter? We may be able to uncover the solution by looking at the conflict between dark energy and gravity. An alternative to dark energy, the cosmological constant, implies that dark energy and gravity are in continual competition. Dark energy appeared to be surpassing gravity and accelerating the expansion of our universe before it stopped expanding. But as of right now, this occurrence has stopped entirely. With our limited knowledge of dark matter and space properties, scientists are unable to come up with a convincing explanation for this disruption. NASA had anticipated the emergence of anti-dark energy, but this specific concept was unanticipated in the present day. According to Brian Cox, the expansion cessation indicates completely new physics. One explanation is that the universe's expansion is finally being stopped by gravity defeating dark energy. If there was a trajectory to our universe, it should have stopped expanding much before it did. Alternatively, dark energy effects could have been suddenly neutralized by gravity. Either way, since gravity has remained constant from the beginning of the universe, we will need strong observational and theoretical evidence to conclude whether gravity is changing. Once a little studied idea, the Big Crunch now seems likely. This cosmic event happens when the universe's average density reaches a point where it stops expanding and begins to compress. A scenario known as Big Bang 2.0 would occur when the gravitational attraction would become so strong that it may breach the space-time dimension and draw everything into a dimensionless singularity that would take us back to the beginning of the universe. The idea that our universe is traveling backward in time has gained support despite not being widely accepted before, especially in light of recent discoveries. A recent study from Princeton University indicates that the expansion is slowing down exponentially, with potentially disastrous results. According to the study, there is a chance that Big Bang 2.0 will happen in a timeframe similar to the 65-million-year-old extinction of dinosaurs. This suggests that the Big Crunch might occur in a matter of cosmic blinks, far faster than previously believed. The Big Freeze scenario, in which the world's temperature reaches absolute zero and everything plunges into eternal darkness, is no longer a threat as our cosmos continues its march toward contraction. Rather, we must confront the horrifying truth of the Big Crunch, a final collapse that will result in yet another singularity. Please subscribe to our channel